And let's go on. Okay, let's take now a look at the calibration curve. The calibration curve comes up by default in the lower right-hand corner. There's lots of information that's available in this cal curve. Okay, one of the first things that we want to look at or take a peek at here is the general shape of that curve. Now, one of the things that I like to do is turn on the internal standards. When I turn on the internal standards, I can tell really how good a job somebody did in adding or aliquoting the internal standard mixture to their calibrators. Essentially, the internal standards, as I bring these green squares up, should be linear or flat. We can see in this particular example that this internal standard maybe wasn't pipetted as accurately as it could be. Then I also have in my calibration curve window some other features here. If I can zoom in by left clicking and dragging and drawing a box around it. We saw Howard do that before. If I want to go back out to the full cal curve, I just hit this, what's a double diagonal blue arrow. And then I also can fit my cal curve to the lowest standard, highest standard, and so forth. I have some drop downs. Also in the cal curve, you'll notice I have the left and right blue arrows, which allow me then to go from compound to compound and view the cal curves. Here is the curve fit that I'm currently using. Right now it's linear. I'm ignoring the origin, and I have no weighting that's involved in there. I also have the ability to turn on those CC levels, those continuing cals. Those will become red triangles in my calibration curve. I can see how close that continuing cal is to that curve. Then I also have any samples that are labeled as QCs in my batch table can become the blue triangle, and you could, tough example, but it's just overlaid here. It's right over the cal point also on here. In the cal curve, I also have my R squared values, my correlation coefficient of variation there. R squared, the closer this is to 1, the better my curve fit is for all the points there. And then I also can set my concentration as relative if I'm using a method of internal standards, or I can put it as actual concentration there as well. Let's try that. There we go. Okay, now to disable a calibration point. All that I have to do in the cal curve is click on that point. It goes from a red circle to a white circle. And essentially then that point has now been disabled. If you notice here, it tells me I have 10 levels in the cal table, but only 9 levels were used. 10 points, 9 points, and then that one QC that we had mentioned before. Whenever I disable a point on the calibration curve, the tip here is always reanalyze the batch to apply this new 9-point curve in this example to all the samples that are in the batch table and recalculate the curve. In addition to this, in the calibration curve window, I also have the Curve Fit Assistant. If I right-click in this window, I get the context menu, and if I select the Curve Fit Assistant, almost instantaneously, I get quite a number of mathematical curves that are possible for this particular data set. As you can see here, there's lots of curves. And if you look at the scroll bar, you could tell that there's been a lot that have been calculated. Okay. I also have ways to evaluate those curves. I have the R squared value. I have a standard error. And then I also have a maximum percent residuals that I can evaluate that curve on. All these columns are easily filterable or sorted. Okay, I could go from high to low just by clicking on the filter funnel icons here. One of the things that does come up when we do this Curve Fit Assistant is the number of points that have been disabled, okay, always comes up to 3 by default. Well, that's readily fixable or repairable. I want to look at all the points, and I want to see which curve fits. So I just click on the filter funnel there. I select 0 points, and then I can now look at the best curve fits that are available to me with all the points being considered. Okay, then in addition to that, I have some other features that I can further evaluate my curve fit with, or my curve fit assistant with. If I right-click again in this upper window here, which has the curve in it, I can turn on a confidence band. I can see the best fit, blue fit, the original fit. It was the black circle, best fit, the blue circle, and then that confidence band comes up. And I could see down at the low end in this particular example that I have, very good curve fit. But as I get out here a little bit further, what winds up happening is my confidence in the ability to calculate that exact concentration becomes a little bit wider. In addition, especially bioanalytical type applications, there's been some papers published recently that are now accepting a log-log plot as a valid plot for using for analytical type data, for quantitative data. We can now turn on in B.08 Quant a log-log plot if we decide to use that. And that's nothing more than right-clicking. X-axis becomes a log axis, Y-axis, log axis. Now I have a log plot. And again, this is just new in Quant B.08. And once I have found a good curve fit that I like, all that I need to do is highlight that curve fit in the table, right-click up in the graphics window and say Accept Curve Fit Assistant. It would then change this to quadratic, ignore, with no weighting. And then next question is, what do I want to do after I've changed that curve? Reanalyze the batch. As we've seen in the batch table, we have properties. As we've seen in the compound information, if we right-click, we have properties, which allows us to customize the display of the graphics. Well, likewise, in the CalCurve window, we also have the same feature set available. Can change the colors of my QCs, CCs, whatever we want to do, show those points automatically every time or not show them. I don't have to use these icons. I can automatically show them here. Hey, Howard, let's take a few minutes here, pass it over to Howard again, and let's look at our Curve Fit Assistant stuff.
All right. Get this brought up here. All right. So here we are. Now we'll be focusing on the calibration curve window down here. Again, notice we've got blue arrows once again. No green. Not really too much utility of being able to cycle through the different runs, but being able to cycle through the different compounds can be useful for trying to review things here. And again, you can note the highlighting in the table changing up here. Also the title here in our calibration curve changing to reflect which compound we're looking at in particular. As Steve mentioned, we can turn on and off our points there, add the internal standard, see how uniform those are across all of our across the different runs and standards. Currently, we've got the QCs shown. One nice little zoom feature here is that we can, with this drop down, we can go to particular points. In some modes, it's not too helpful, but say if we want to just look at, say, the middle of the curve, we can click and drag, and then that gives us a nice zoomed in view of that region. or if we just want to look at our high-end points, okay. So this is a nice way to kind of be able to focus on different points without trying to manually zoom in. And, of course, as with most MassHunter applications, we've always got our full zoom back out button there, okay. Again, lots of ways to get back to defaults and get out of anything that was done either on purpose or inadvertently. Let's see. Let's go ahead and for now, we'll leave those on for a moment. The other thing, and it has already been mentioned in some of the questions about turning off the points. So again, that's, so you can see if I hover my mouse over there, get a little delete X, it also pops up all the information about where that particular point came from. But if I want, I can just turn it off. You can see here the calibration table immediately reflects that that point was turned off. Okay, our line changed, our R² has changed, and it's just as easy to turn it back on. But again, note that as I'm doing this, nothing's changing up here in our tables because I haven't analyzed the batch. So if I want to see how things look like with that, and this is our meth results here, just kind of keep an eye on that final concentration column. If I now reanalyze the batch, okay, you'll notice that now we've got slightly different numbers here, okay. We turn it back on, again, calibration changes, but no changes here until looking at the curve assistance. Let's just temporarily turn off the QC. So these are just our calibration points here, nothing else. Again, right-clicking, we can get to the curve fit assistance, which is a nice tool. By default, you'll notice it's sorting on the R², and once you remove 3 of these 5 points, it's obviously pretty easy to get the R² to 1. So let's just say I want to see what options I have with no disabled points. And again, it just kind of runs through every possible mathematical way of finding the best line. Now, obviously, not always are going to be valid for all different types of analyses or methods. Okay, so just keep that in mind, that it is showing you all the valid mathematical ways of getting a line through these points that may not be valid analytically or necessary for your particular application. So we can, then turn off if we want to just look at the different options for what happens if we, don't weight the individual points, okay? And you can see that's starting to limit things more as we go through and click on these. Then we can see what our current curve is and then what our new one would be if we were to choose this particular one. The blue line there, which you can see, would show the difference in the new curve versus our old curve. We can also turn on the confidence band. Again, if we want to see kind of how things change there. I think for this, let's kind of go with this. To me, this looks a little bit like a quadratic. Again, I'm still going to want to ignore the origin and no weighting. And so say if I like this one and I want to accept it, then I can just go and accept assistance curve. If I didn't want to, I'll just point out that all I would have to do is disable the curve fit assist and nothing would have changed, okay? But if I simply do accept assistant curve, and now it's changed, okay? And again, we get out of this, and now we can see our new curve. Again, the dialog boxes up here reflect that. But once again, to make this active, we need to analyze the batch. And now we can see our new results with the new curve. Okay?
Okay, I have a question here. The curve fit assistant can be unwieldy sometimes because it displays types of curve fits that I know I don't want to use. Can I exclude certain types by default so they don't clutter up the list of curves?
The answer to that is no. Okay, when you activate the Curve Fit Assistant, basically what's happening there, it gives you all the mathematically valid type curve fits. You and I, as analytical chemists, will exclude many of those. Let's put it that way. Okay. However, as Howard's showing us right now, we can look at just certain types of curve fits to narrow that window down. Say I want to stay with a linear curve fit, as Howard's showing us right now. Here are all my linear curve fits that fit the data set.
Yeah, and we can activate as many of these filters as we want all the way across. So if I only want to see, linear ones, and say I care about the weighting, okay, and say none. So now I can see my options with only the filtered linear, with these, and these are the different ways that it would affect it depending on what I do with the origin. Again, yeah. Unfortunately, no way to default filter, but the filtering tool is there, and you can use that once you get into it to at least limit what's presented to you from there. But.
Okay. What is a typical acceptable range for variation in the internal standard values among calibration standards?
That's a little bit of a loaded question. Okay. Typically, when we brought up that the green squares turned on the internal standards, we would like to see that be as linear as possible. But in reality, what I do note, and you can probably see it in this one, is that as we went to the higher concentrations, right, we now have this internal standard response being much lower than the other four values here. That's probably due to a phenomena called ion suppression that we are encountering right now. Okay? In the source, when we're ionizing these compounds, there's only so much ionization that can take place. But you have to remember that at these higher concentrations, right, that's going to be constant. The internal standard amounts in all our calibrators and all our samples at the same amount. So there's no real answer to how it should look, except it should be as flat as possible. And then I always make the exceptions that at the higher concentrations, when I'm going over several orders of magnitude in my concentration, that I will see a fall off in that internal standard response at the higher levels, and that's more than likely due to ion suppression within the source.
Okay, thank you. Let's check the phone lines. Alan, anybody that has pressed *1?
At this time, no questions over the phone lines.
Okay. Another question here. Just for clarification, renaming a user-defined column cannot be accomplished within MassHunter Quant?
Renaming
a user-defined column.
I think what they're asking us there is the header information, user-defined 1, 2, and so forth. I would have to check into that. There may be a configuration file that's available. Is the user-defined field an editable field in the batch table? Yes, I believe it is, because we could fill in the values in the batch table.
Okay. And if this person would like further clarification, just drop us another question. We'll certainly get to that one shortly. Another question here.
Let's save that one also as one to look into for us, Lindsay, okay?
Sure.
We'll research that one a little bit more.
Can the software do calculations for a standard addition experiment? And if so, how?
Oh, that's a segue into...
Okay, we'll hold on to the next. We'll hold on to that.
We're going to hold on to that one, okay?
Perfect.
All right.
What is perfect. What is the acceptance of different curve options by regulatory bodies?
You'd have to check with your regulatory body as to what their preferences is, what the acceptance values are. Okay? It varies greatly. Clinical has some certain criteria that they need to use. whereas EPA methodology, a quality control operation locally would probably have their own criteria to utilize. So I can't really answer that one because it depends upon the regulatory agency and what their criteria is. In the MassHunter software, we're giving you lots and lots of options.
And being that this is a global webinar, it really can range.
Yes.
Okay.
Yes.
In Quant with QTOF, is it more usual to use an internal standard or, as in the case of UV detector, or as in UV detector, or not to use one? Pardon me.
All right. Using an internal standard and not using an internal standard, okay? There are several methods that are available to us for quantitation. Okay, we had the question just a few minutes ago with method of standard addition. Okay, method of standard addition is a very accurate method for determining the concentration of samples because what you're doing there is you're taking into account any matrix effects. Then we have method of internal standards. A method of internal standard is we relate our compounds to one or more internal standards. Now, the response factor of this internal standard may not be the same response that we're going to see from our targeted compounds. So in many cases, what they will use is isotopically labeled internal standards. You can be pretty much rest assured that the response factor for an isotopically labeled, a D3 amphetamine or a D5 methamphetamine, as we're seeing right now on Howard's screen, that response factor for the deuterated compound is going to be very, very close, if not identical to the response factor for the methamphetamine. So using isotopically labeled. Then we also have the method of external standards. Okay, this is just where you're making up a solution. It has no internal standard in there. So it doesn't account for any variations in injection volume that may occur or any responses that could change due to matrix effects that are in the samples that we're running. And then the last method of quantitation is the semi-quant. Semi-quantitation is not very accurate. It's not going to tell you exactly how much is in there because your response factor for the target compound that you're looking at may not be accurately determined. I hope that answered that question, but that's basically what's happening in the quantitation world. There's a lot that's going on. Most people wind up using the method of internal standards, and the reason why is the method of standard addition requires a minimum of 3 runs to get one answer. Now, in an LC world where the runs are generally much shorter, that's fine and acceptable. But when you're looking at a GC world where you're separating columns and once again your runs can be 30 minutes or longer, right? It's not really feasible to have to run for 90 minutes to get one answer. You have to run through the samples much faster than that.
Okay, one last question here. Can we flag results that are higher than MDL in the batch table?
Yes. Okay. Howard, if we go into method editor and outlier tasks, we will see that we can, well, maybe I didn't listen. You said higher than the MDL.
But it said higher?
Right.
Higher than MDL.
The answer to that would be no, because the MDL, which just went past, is at the top of your list there right now. Yeah. Okay, limited detection, limit of quantitation, and method detection limits are really only one-dimensional. What we're interested in is if a value is below our limit of detection, I should probably be throwing that out. Limit of quantitation, okay, how low can I go and get reproducible quantitation results? And then a method detection limit has slightly different definition, but again, it's one-dimensional where I'm only interested in values that fall below this, so I can't really flag a LOQ, LOD, or MDL above if it's above. It would be not an outlier in that case.
Right. Well, and I guess what you could do if you wanted is to set the outlier and then make it so that in the batch table you only show the rows or columns that don't contain any outliers. And then you wouldn't see the ones that were below. You would only see the ones that were above. Or, yeah, well, as you say, it is kind of a one-dimensional. You know, we only have one column for this, whereas for the ones that are, well, okay, that's not the best. Let's see if I can find one that, no.
Yeah, keep going.
And of course, yeah, keep going. I'll find one eventually. Yeah. So here's an example of, I guess, what we would consider a two-dimensional. So we've got a low limit and a high limit for the internal standard response limit. So we can, you know, if we know we're expecting a certain internal standard response, we can set a high and a low limit for that so that any runs that fall outside of that range will be flagged as either blue or red, low or high. But then certain other things, again, kind of like a signal-to-noise ratio is another one that's, you notice we only have a minimum. We don't make an allowance for a maximum. Most people aren't concerned that, you know, if they're getting 20,000 signal-to-noise, that's great. But they'd be concerned if they were getting less than 5, say. So a lot of these are, as Steve, we kind of describe them as one-dimensional. We only have a lower limit in this case for those.
Okay, and I have one last question, and then Steve will get back to you. And just because we're right here, would you please show how to add user-defined columns and which parameters can be used as user-defined?
User-defined columns. All right, if we want to add those, typically they're added in the batch table.
Oh, pardon me.
That's okay.
Again, we're running into some issues with the user-defined. What do you want to user-define here? And that's why I think what we're going to try to do here is to address this offline.
Okay,
we can have user-defined columns, and then we can implement those into an outlier possibility or a, just it's user-defined. Here's the variable. What do I want to do with it? How can I handle it? What do I want to do with it? I may need to put in a custom calculation to take into account that user-defined field. Or a user-defined field can be just text information, you know, first extract, second extract, or whatever the case may be. So we have that information then readily available to us in the batch table to know what we're looking at.
Okay, that's perfect. Thank you. And Steve, back to you.